Hello, good morning, students. Hello,
Good morning, sir.
very good morning to one and all. So today we are going to discuss the important chapter and the interesting chapter, maxima and minima of functions of two variables. So we have already in the first unit, we talked about maxima and minima for a function with one variable, right? Usually the one variable function, right, we call it as a curve, y equal to f of x, right? And we have analyzed this function, right, based on first derivative test and second derivative test, right? And in the second unit, right, now we are going to see the maxima and minima for the functions with two variables, f x comma y, right? And this is can be written as in terms of z. So we know that this is a surface, right? This is a surface, and this is a curve. Y equal to f of x is a curve in two dimensions. This can be represented in three dimensions. Here, x and y are the independent variables, wherein z is a dependent variable. We can plot, right, in the three dimension, right, for x and y, a point is given to the function f x comma y. Correspondingly, that value can be taken as the height actually, or we can take it as an z-axis. If you see that this will be a three-dimensional point, x comma y comma, the functional value of x comma y comma, f of x comma y, which is nothing but z. So here the question is, where is maxima and minima occurs, right? So sometimes I can say that the value is maximum, right? I can say that the value is maximum. At a particular point x comma y, the height, we call it as z, or we can call it as f of x comma y. That value is maximum, right? When can you say that this function is maximum, right? Or sometimes we can say that the function attains a minimum at a particular point, right? A minimum value of the a particular function, or sometimes neither maxima nor minima, we call it as a saddle point, right? According to the definition given, let us take the definition. A function in two variables, f x comma y, is said to be or is said to have a maximum value or a minimum, right, at a point a comma b. A comma b means a point a comma b, right? According as f of a plus h comma b plus k must be less than f of a comma b. So what do you mean by that? What do you mean by that? Anyone? Can you guess? What it says? When can you say the function is maximum? Right? If f of a plus h and b plus k must be less than this value f of a comma b. So I claim this point a comma b, right, is the point wherein if I substitute the values for a and b, this value is going to be a maximum value if I choose a neighboring point of a and b, right? Say for example a plus h. A plus h means this is to the positive side of h. A minus h means to the negative side of that particular point. A, or here it is x, right? If you substitute this value, that value must be always less than this what you have claimed as the maximum value. Say for example, if you say that at the particular point 1 comma 2 the function attains the maximum and the maximum value is 100 means, so whatever value the point you have given across 1.1 or 0.9, right? This is plus h and this is minus h for this particular neighborhood. And again, 2.01 or 1.99, a neighboring point of that particular value. If I substitute this value, say for example, f of 1.1 and say 2.01, you will be getting an output value. That output value must be always lesser than what you have claimed the 100, right? So, and moreover, this is not the case. And even if you go with some negative values of that particular point, say 1 minus a very small value, say for example, f of 0.9, and this is 1.999, you will be getting some value. that value must always be lesser than this value 100 or what you have claimed to be the maximum. So that is the definition. We say that the function is said to be a maximum at a particular point a comma b whenever if you substitute a neighboring point on that particular a and b. Neighboring means plus h or minus h plus k or minus k. That value will be always remains lesser than what you have claimed to be the maximum value. Similarly, for minimum, for minimum, this value f of a plus h, b plus k must be greater than this value f of a. The same argument can be continued if you assume that f of a comma b, right, at a particular point 1 comma 2. So you claim that this is minimum value, say for example 10, right? And in whatever the interval you have, so not 1 comma 2, we have taken somewhere else, say for example 3 comma 5, the minimum value is occurred and the minimum value is 10. Say for example, right? Then according to the definition, what it says that if you say that this 10 is minimum and nearing that neighborhood, which means that if you substitute to the function f(x, y) with the nearing point, say 3.01, maybe 4.99, that value, if you got that value, must be dash. Can you tell me? If you say this is minimum, that value must be, anyone? F of 3.01, 4.99 value must be. Can you complete the statement? Yes?
Sir, must be less than 100, sir.
I'm talking about minimum. If you claim that 100 is maximum, to that neighboring point of 1 comma 2, if you substitute any value, that output will be always lesser than that of 100. If you say claim that 10 is a minimum at a particular point 3 comma 5, then whatever the inputs you are giving, neighboring to 3 comma 5, right, 3.01 or 4.99 or 5.01, that value must be, if you claim that 10 is minimum, that value must be
greater than
10, sir.
இதை விட கம்மியா எதுவும் இருக்க முடியாது சார். 10 மினிமம் சொல்லிட்டீங்கன்னா அந்த நெய்பர்ஹுட்ல 10 விட கம்மியான ஒரு வேல்யூ இருக்க முடியாது. ஸோ மஸ்ட் பி கிரேட்டர் தேன் 10. அதே போல மேக்சிமம்னு ஒரு ஆளை சொல்லிட்டோம்னா, இப்போ ஒரு கிளாஸ்ல வருதான் மேக்சிமம் மார்க். ஐ கிளைம் தட் த மேக்சிமம் மார்க் இஸ் 99 அப்படின்னா, there is no other person, right, will have the mark more than 99. So therefore, the same claim can be hold for minimum value. So if I claim that f of x comma y attains its minimum at a point a comma b, if f of a plus h, b plus k must be greater than f of a comma b, then it is the definition for the minimum. So this is an example which was illustrated with assuming that f is a function with two variables and f attains the maximum value at a particular point, say p 1 comma 2, and its maximum value is 100. If and only if, or if it can, the statement is good only when if you go with the neighboring points of whatever may be the neighboring points, right? Go with 1.1 or 2.01, whatever the input you get, any input must be less than 100. It should not exceed that 100, which means f of a plus h comma b plus k must be less than that functional value output f of a comma b. Similarly for minimum also, that has been depicted here. Suppose q is a point 3 comma 5 wherein the function attains the minimum, and the minimum value for the function f is 10, if and only if, or we can claim that function is, that value is minimum only if you substitute the values, right, nearby to that particular points, right, a plus h, b plus k, that value must be greater than this value f of a comma b or 10. Then we can say that this is the minimum or maximum. So saddle point means you can, in that particular case, you can have neither maxima nor minima, right? It will be like a constant, right? Values will never change. So this is the basic definition for the maxima and minima for the functions of two variables, right? So how many of you are present? 45, thank you. Okay. All right. So what will be the problem actually for you actually, right? You will be given a function with two variables, and the question is find the maximum value and the minimum value for the function f x comma y if it exists. That is the one question. Second question will be at what point the function attains the maximum, and at what point the function attains minimum if it exists. So this is actually can be done by a very good theorem, right? The necessary condition for the function to have either maxima or minima at a point a comma b means this fx. Fx means the partial derivative of f with respect to x, dou f by dou x.
Right.
At the particular point a comma b must be 0, dou f by dou y at the particular point a comma b must be 0. So this is the condition. So in one variable we say that put f dash of x equal to 0, right? This is what we have done. That is differentiation with respect to x for the function f of x. We will be equating 0 and we will be getting the points for x, say for example 1, -1, 2, and we call these as a critical points, right? Similarly, for two variables, we have two types of differentiation possible. First order, one with respect to x, other with respect to x. Therefore, in order to find, we call here it as a stationary values. அங்கே நம்ம critical point ன்னு சொன்னோம், இங்கே stationary values ன்னு சொல்றோம். So how to do that? அங்கே ஒரு தடவை differentiate பண்ணி equate to 0, we find values for x and we claim that values as the critical points. Here in two variables, we have to go with partial differentiation with respect to x. You name it as equal, put equating to 0, take it as equation 1. Again, partially differentiate the same given function. This will be the given function, right, for examination. And you have to do the partial derivative with respect to y, and you have to equate it to 0. Then solving these two equations, what do you get? என்ன கிடைக்கும் பாருங்க solve பண்ணா. இங்கே f dash of x equal to 0 ன்னு solve பண்ணா x equal to 1, -1, 2 அந்த மாதிரி கிடைக்கும். இங்கே solve பண்ணா என்ன கிடைக்கும்? Any idea? Yes?
இங்கே x கிடைக்கும் சார், x and y கிடைக்கும் சார், x plus y ஒரு ஈக்குவேஷன் மாதிரி கிடைக்கும் சார்.
ஈக்குவேஷன் மாதிரி கிடைக்கும். குட். இங்கே ஈக்குவேஷன் மாதிரி கிடைக்கும். சால்வ் பண்ணா என்ன கிடைக்கும்?
x ஒரு காம்போனன்ட் இருக்கும், y ஒரு காம்போனன்ட் இருக்கும், ரெண்டு சேர்ந்து ஒரு
ஈக்குவேஷன். We get the points x, y, p1, x1, y1. Second point p2, x2, y2. இங்கே வந்து x1 equal to 1, x2 equal to -1, x3 equal to கிடைச்சது மாதிரி இங்கே we get a pair of points because it is a two dimension. It is a two dimension. We need a point x coordinate as well as y coordinate. Appo here you will be getting a point x1, y1, p2, x2. These points we call it as the stationary values. In the points we have to go for checking whether the function is going to be have a maxima or a minima or neither maxima nor minima. So therefore we have to do, this is the necessary condition actually, fx at the point a comma b equal to 0 and fy at the point a comma b equal to 0, which means that we equate it to 0 and we find those points and we call it as a comma b. Okay. So இப்போ எப்படி சார் இந்த ப்ராப்ளத்தை வந்து நான் செய்யறது? ஒரு ப்ராப்ளம் கொடுத்துட்டாங்க, given fx comma y. Question is find the maxima and minimum value for the function fx comma. This can be done in 3 steps. The first step is find. So you will be given fx comma y. You will be given fx comma y. The function will be given. The first step is find dou f by dou x, dou f by dou y. Second, you equate it to 0. Equate it to 0. Make it as equation 1. Dou f by dou y equal to 0. Make it as equation 2. This is the first step. Then, after this, if you solve these points, you will be getting so many values. P1, x1, y1. Example, sir. Say for example, -1, 2 is a point. P2, 0, 1 is a point. P3, 1, -1. So you will be getting different points. We call it as a stationary points. We call it as a stationary points, right? This we call it as A, B. You can call these points as A, B. How many points we got depends on the given curve. You may have 2 points or 3 points or 4 points, right? It depends on the given function. You will be getting more number of points. We call it as a stationary values. Next, second step is actually you have to go for finding the second order. You have to go for finding the second order. So I'll explain the step number 2. Step number 2. You have to find the second order dou square f by dou x square. Then dou square f by dou x dou y. Dou square f by dou y square. You have to find all these quantities. Okay. You name it as RST. In some other book, it has been given as ABC, PQR. So here in Gravel, this is given as R, this is given as S, this is given as T. What do you mean by this, sir? So you have F, we can find Fx, we can find Fy. This is Fxx, which means go to Fx, differentiate with respect to x partially. You get dou square f by dou x square, which is named as R. And similarly, S is dou square f by dou x dou y. And T is referred to dou square f by dou y square. So this is the second step. Next, you can make a tabulation column. You can make a tabulation column. In the tabulation column, we can find R value, we can find S value, we can find T value. For so many points, suppose the first point is x1, y1. The second point can be taken as P2, x2, y2. So we can substitute at x1, y1 the first stationary point, right? Say for example, x1, y1 means find the value of R, find the value of S, find the value of T. Similarly, if you have n number of points, stationary points, we can find and we can make the tabulation column, right, for the values for R, S, T. So if you put the tabulation column, then it will be easy for you. And step number 3 is the decision-making step. Decision-making step, right? One of the stationary points, right, will be the your maximum, right? It will be the point wherein the function will be maximum or minimum, or either maximum or minimum, that you have to identify. So what we have done so far, we have identified the points P1, which is x1, y1. Next P2, x2, y2, etc. Then we try to calculate the value for R, okay, S, and then T. The next one is R times T minus S square. This quantity you have to calculate. So that is that comes under the next one, right? RT minus S square. Sometimes in your book they call it as a discriminant, because it is delta, not discriminant. It is delta. This is going to give some decision making, right? Whether it's greater than 0 or less than 0 or equal to 0. So the next step is find R times T minus S square. Where is R, sir? R is here. How it got, right? It's actually dou square f by dou x square at the point x1, y1. In that at the point x2, y2. So how many points stationary points you have, you can go across those points and you can fill the tabulation column. So RT minus S square value, this is R, this is S, so this is T. So R times T minus S square value will be depicted here. Okay. So this R times T value, right, RT minus S square value will be placed here. So now the decision. Now the last one is the decision making, right? What is the decision? So please see the third step. If RT minus S square, which is in my case delta, is greater than 0, and R is less than 0, please note it down. Please take your notes. This is very important. Decision making. If RT minus S square, or you can name it as delta minus S square, is greater than 0 and R is less than 0, then you claim that this point is a maximum, right? At this point, the function attains maximum. Okay. If RT minus S square greater than 0 and R is less than 0, then at this particular point, the function attains minimum value. Okay. Instead, RT minus S square greater than 0, if delta is not greater than 0, if delta is less than 0, then you can straightly claim that the function, right, at that particular point, A comma B, is not an extreme value, right? It is a saddle point. You can say that it is a saddle point. Okay, so we get a maximum value, minimum value condition, saddle condition. There is one more possibilities. Sir, what happens, sir, if delta equal to 0? Right? This is a doubtful case. You need further investigation. That further investigation will not be allowed here for a university examination. So further investigation means you have to go for some plotting the graph, right, which needs more time for you. Therefore, most of the case, this delta may not be 0, right? Delta may not be 0. And if delta equal to 0, a careful inspection has to be done because the test fails. So I just want to review just what I have been taught. You will be given a function f(x, y). The question is find the maxima and minima for the function if it exists, right? That is the question. So step number 1, I'll do the partial differentiation with respect to x, dou f by dou x, then dou f by dou y, and then I'll be equating it to 0. I'll be equating it to 0. I name it as equation 1 and 2. Solving, I'll be getting the values for x and y, and I'll just plot it as P1, P2, P3, and these points are called stationary points. Then I'll be going for finding the second derivative, and I name it as R, S, and T, and then I'll go for go for the tabulation column. Then I'll check with the conditions, right, whether this R value is less than 0 or greater than 0, and the delta value is greater than 0 or delta greater than 0 or less than 0, right? And depending upon that sign, I'll go for the decision making whether the function attains maxima or minima at a particular point A comma B, right? And if so, then I can find the maximum and minimum value, and that problem will be solved. Shall we go for the problem? Hello?
Yes, sir.
Yes, sir.
Okay. It's a very similar type, right? We'll go for a problem. So let me give a very simple problem for you. Find, please take down the problem. Find the extreme value. Find the extreme value of the function. Find the extreme value of the function f(x, y) equal to x cube plus y cube minus 3x minus 12y plus 20. I repeat, x cube plus y cube minus 3x minus 12y plus 20. Okay. So this could be the 8-mark question for Anna University if it's a theoretical one, right? So what is the first step? Anyone can tell me? What is the first step?
Dou of dou x.
Yes.
Yes.
We find dou f by dou x. Okay. Dou f by dou x. What is dou f by dou x here?
3x square
3x square minus
3.
Minus
3. Okay. Then find dou f by dou y. Find dou f by dou y. You will be getting 3y square
Minus 12.
minus
minus
12.
12.
Sir, next equating to 0, sir.
Very good. That is the necessary condition. Put dou f by dou x equal to 0 and dou f by dou y equal to 0. ரெண்டுமே 0 போடும். So we get 3x square minus 3 equal to 0, make it as equation 1. 3y square minus 12 equal to 0, make it as equation 2. So if you divide it by 3, you get x square minus 1 equal to 0. The second equation is y square minus
minus 4 equal to 0.
minus 4 equal to 0. So இந்த மாதிரி ஈஸியான ப்ராப்ளம் ஏன் கொடுத்தேன்னா இது இண்டிபெண்டன்ட் ஆஃப் எக்ஸ் அண்ட் ஒய் இங்கேயே இருக்கு, அதனால டைரக்டாவே சால்வ் பண்ணிடலாம். ஸோ 1 implies x square equal to 1. X can take the value plus or minus 1. Okay. 2 implies y square equal to 4. Y is equal to plus or minus 2. Y equal to plus or minus 2. So therefore the stationary points are, can you tell me what are the stationary points? How many points you have?
2 points.
4,
How many points you have, stationary points?
4 points. Sir.
4 points.
X1
4 points. You have all combinations, right?
8.
So, how much? 8? How you got it? 8.
Because by
Wow.
interchanging with
You
the-
have 4. No. That x must be, x can take the value. So you have P1. X can be 1. But 1 can, this is both are positive, right? 1 comma 1. P2, this is, it can be 1 and it can be negative, minus 2. Then third point is minus 1. X can be minus 1, it can be positive. And
Minus 1, minus 2.
minus 1, minus 2. So these are all the stationary points. So therefore you have to claim this, therefore the stationary points are the stationary points are 4 points you have got. Okay. I have to make as a note. Then what is the step number 2? The easy
Sir,
question.
dou square x, dou
Yeah.
square f by dou x square.
Yes. Dou square f by dou x square. Can you remember what is dou f by dou x?
Yes, sir. 3x square minus 3, sir.
3x square minus 3. Dou f by dou y. We also know dou f by dou y is 3. Y square
minus 1.
minus 12. So this is there. Okay. So dou square f by dou x square means this is fxx. You go to fx, right? Do differentiate with respect to x. What do you get? 6x.
6x.
Okay. Next, dou square f by dou x dou y, which means this is fxy. How to find fxy? Go to fx, differentiate with respect to y. You get 0. Then find dou square f by dou y square. This is fyy actually. How to find fyy? Go to fy, differentiate with respect to y. You get
6y.
Okay. So this will be named as R. This will be named as S for our convenience, right? Because
40 minus s square.
no. Just you named as R. Is another?
Yes, sir.
Yes.
Yes, this is T. This is
T.
Now you have to go for tabulation column. You have to go for tabulation column. How to do the tabulation column? So points will come. Have to go for the tabulation column. Okay. So the first point is 1 comma 2. You can write it as 1 comma 2. In the second column, you have 1 comma minus 2. Third column, you have minus 1 comma 2. Last column, minus 1 comma minus 2. What needed. Okay. And here the subdivision you have R equal to 6x. S, this is equal to 0, whatever maybe it is the point. And T equal to 6y. You have to make it as a table that will help you. Just I use the ruler. Okay. Fine. You want two more which is needed. This will be the last one. Okay. Let me find okay. So what is R value for the point 1, 2? You have to put x is equal to 1. You have to put x is equal to 1, y equal to 2. What do you get the value R for this point 1, 2? 6. This is greater than 0. This is always 0. And this is 6 2s are 12. This is greater than 0. And you have to find what is the thing you have to find? Next one.
R times of T minus S square.
RT minus S square. You have to find RT minus S square. So this is RT minus S square. So this R is 6, T is 12, R into T. 6 12s are 72 minus S square 72. This is also greater than 0. Okay. Now here conclusion. What is the conclusion? RT minus S square greater than 0 and R is greater than 0. Go to the point.
Minimum
RT
value.
minus S square greater than 0. RT minus S square greater than 0 and R is greater than 0. So this point A comma B, at this particular point the function attains the minimum value. So you have to say that at the point 1, 2 this is minimum. Next, let us go with second point, 1, minus 2. Here also, you will be getting 6 greater than 0. S is always 0, whatever may be the point. And Y is minus 12, which is less than 0. Now, let me find RT minus S square. R into T. R into T. Minus 72, which is less than 0. So what is the case when RT minus S square, we can call it as delta, right? RT minus S square less than 0 and R greater than 0. What is the conclusion? RT minus S square less than 0 means this point is a saddle point. This is a saddle point. Okay. Now let us go for minus 1, 2. You will be getting, if x is equal to minus 1, this R value becomes minus 6, less than 0. This is always 0. This is plus 12, greater than 0. R into T. R into T. R into 2 minus 72. Which is less than 0. So this is also saddle. Saddle. Okay. Now let me come with minus 1, minus 2. This is R is minus 6, less than 0, always 0. This is minus 12, less than 0. This is 72, greater than 0. So RT minus S square greater than 0 and R is less than 0. What is the conclusion?
Maximum value.
Maximum value in the point function maximum. The function will be maximum at this point minus 1, right? So therefore, we can find the maximum value. Okay. So this we call it as an extreme value. Conclusion, this is extreme value. What is the extreme value? This is the minimum value. You have to substitute the values for 1, x equal to 1 and y equal to 2 in that equation.
Function, sir.
Yeah, in the function. In that function. So what is the function? Can you tell me what is f of x comma y form now?
X cube plus y cube
Y cube.
minus
minus
3x
3x
Okay.
minus
minus
12y
12y
Okay.
plus 20.
Plus 20. Now, this saddle point has no maximum, no minimum value. So this is going to be the minimum value at the particular. So we want to find 1, 2. 1, 2 go down now. 1 plus 2 cube is 8. 2 cube is 8 minus
Minus
3 minus 12 2s are 24 plus 20. So you get minus 20. This is minus
2,
4
sir.
minus 7. You get
2, sir.
So the minimum value is 2. The maximum value is f of minus 1 comma minus 2. What is the value you are getting?
Minus 1.
Minus 1.
sir minus 2 sir.
You'll know this 2 plus 2. And this is 38. And the answer was the?
38, sir.
This is minus. Okay. And this is, if you get minus 1 the whole cube, you get minus 1. Minus 2 the whole cube is minus 8. And this is plus 3.
3, sir.
And this is plus 24. And this is plus 20. So, 27,
38.
47, 47. How much you get?
38.
38. So this tabulation column. So you have to conclude. What is your conclusion? The function f x comma y attains maximum at the point minus 1 comma minus 2 and attains minimum at the point 1 comma 2 and the maximum value is 32 and the minimum value is 2. That is the conclusion. So இப்போ என்ன மாதிரி வரும் அப்படின்னா this is easy problem for you, but sometimes you have to solve equation 1 and 2 will be a challenge. So what is the challenge in this problem? Finding dou f by dou x is not a challenge. Finding dou f by dou y is not a challenge. Equating to 0 by making it as equation 1 and 2, solving for that will be a challenge. இங்க ஒன்றும் அப்படி அமையல ஏன்னா this is independent of x and y. x y தனித்தனியா இருந்தது. Easily we have solved for the values of x and y. So let us take another example. Shall we go?
Yes, sir.
Okay, fine. So we'll go for the third example in our book. So let me take this problem. 2. Examine the following function for extreme values. F of x comma y equal to f of x comma y is equal to x to the power 4 plus y to the power 4 minus 2x square plus 4xy minus 2y square. So let me do that problem now. So let us find dou f by dou x. We get 4x cube minus 4x plus, if you
4y.
look, yeah, plus 4y, yes, correct. And dou f by dou y, this is equal to dou f by dou y, this is equal to 4y cube 4y cube. Okay, and there is the y term is absent, so 0. So here it is 4x, and here you will be getting minus 2 to the 4y. So let us also find dou square f, because this is needed. Dou square f by dou x square. We call it as r. In some other book, it will be written as ABC, no issues, right? Dou square f by dou x square. What do you get? 4 3s are 12.
12x square.
X square minus 4. And S is dou square f by dou x dou y, which means go to dou f by dou x. Okay. Differentiate with respect to y. You get 4. And this t is dou square f by dou y square, which means go to dou f by dou y, okay, differentiate with respect to y. So you get 4 3s are 12 y square, 12y square minus 4.
Yes, 4.
இது வந்து செகண்ட் ஆர்டருக்கு தேவைப்படும், அதனால இப்போதைக்கு செய்து வச்சுக்கிறேன். For me, you can also find it.
Sir, first order equating to 0 பண்ணனும்.
Yes, put dou f by dou x equal to 0 and dou f by dou y equal to 0. Put dou f by dou x equal to 0 and dou y by dou y equal to 0. So what do you get?
And it's divided by 4 போட்டுக்கலாம் sir.
Whatever it is, you can do it, but I want the answer. So this is equal to 0. Make it as equation 1. This is equal to 0. Make it as equation 2. So as he said that there are some common terms available, you can cancel it. So you can have the term like x cube minus x plus y equal to 0. This is your new equation number 1. இப்போ பார்க்கலாம் உங்க challenge. I want to find x and y because it is not independent. A term is an expression in x and y, both in the two equations, right? So this is y cube plus x minus y equal to 0. I want to find the values of x and y satisfying these two equations. யாரா சொல்ல முடியுமா என்ன பண்ணலாம்னு ஒரு ட்ரிக்
Equating both equations, sir.
Sir, adding 1 and 2.
Well done. யாருப்பா அது பேர் என்னப்பா?
Elimination method use பண்ணலாம்.
Very good, very good. இல்ல whatever by means, this is skill. ரெண்டு ஆட் பண்ணா அந்த x உம் y உம் ஓடி போயிடும். So ஆமா, it will eliminate it. X 1 plus 2 implies I will be getting x cube plus y cube equal to 0. This implies x cube equal to minus y cube, or you can write it as minus y the whole cube. So which implies x equal to minus y. X equal to minus y. But இதை வச்சு நான் என்ன பண்றது?
அதுக்கு போய் அந்த ஈக்குவேஷன் அப்ளை பண்ணலாம்.
Well done. இதை எடுத்துட்டு போய் அதுல சப்ஸ்டிட் பண்ணா x க்கு என்ன y க்கு என்னன்னு தெரியும். I know that x and y they are equal and opposite in magnitude, but I want to find that value. என்ன வேணாலும் இருக்கலாமா அப்படினா இருக்க முடியாது. So you can either substitute in equation 1 or 2. So substituting in equation 1 we get, okay, என்ன பண்ணலாம் சார்? x இருக்கிற இடத்துல y போடலாமா, y இருக்கிற இடத்துல x போடலாமா?
x இருக்கிற இடத்துல y போடணும்.
x இருக்கிற இடத்துல minus y போடணும் அப்போ. So x இருக்கிற இடத்துல minus y the whole cube, okay, minus x இருக்கிற இடத்துல minus y, then y இருக்கிற இடத்துல y ஐ போட்டுக்கலாம், equal to 0. All right. So you get minus y cube. This is what is this?
Plus 2y.
This is plus y plus 2y equal to 0. You can take y common. 2 minus y square equal to 0.
Y equal to 0.
Y equal to 0, or 2 minus y square equal to 0. So y square equal to 2. Y equal to plus or
Sir,
minus
minus root 2, sir.
square root of 2. So 3 values for y. So therefore 3 values of x can be there and it can be plotted. Can you tell me what are the stationary points now?
Root
What
of
are the stationary points? So x is equal to 1. So when x is equal to 0, sorry, when y equal to 0, well, that's what we have found. When y equal to 0, if you put y equal to 0 in this equation, we get x is equal to 0. So therefore, the first point P1 is 0, comma 0. That's the stationary point. Then I got y equal to plus 2, plus root 2. When y is equal to plus root 2,
Minus root.
y equal to plus root 2. What is x? X is equal to
Minus root 2.
minus root 2. So therefore, the second point is minus root 2, comma plus root 2. Because I have to write x coordinate first, then y coordinate. Then I find y equal to minus root 2. Y equal to minus. When y equal to minus root 2, I will be getting x is equal to plus root 2. So what is the third point, stationary point? What is the third stationary
root 2,
point?
minus root 2.
Yes,
Plus root 2, minus root 2.
yes. So the third stationary point here is x is equal to root 2, y is equal to minus root 2. And therefore, this can be taken as a column. We can find the R, S, T at this particular stationary values. Then we find RT minus S square. Then we come for the conclusion. So therefore, we have 3 points. You take it down.
No doubt, sir.
Innaba?
சார் போன சம்ஸ்ல வந்து நீங்க வந்து மொத்தம் 2 பாயிண்ட் கிடைச்சதுனால வந்து 4 பாயிண்ட்ஸ் கிடைச்சு சொன்னீங்க சார். அது மாதிரி சம்ல வந்து 4 பாயிண்ட்ஸ் கிடைச்சிச்சு. 4 பாயிண்ட் கிடைச்சிச்சு சார். இதுல வந்து பவர் 4 இருக்கிறதுனால வந்து 6 பாயிண்ட்ஸ் கிடைக்காதா சார் இந்த இடத்துல?
இல்ல 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 சொல்றேன், முடியும். செய்ய உங்களுக்கு ஒரு ஐடியா கிடைச்சு எதை பேஸ் பண்ணி இது வருதுன்னு சொல்லி. ஓகே, ரைட். Now let us go for this is P1, P2. Okay, நீங்க சொல்லுங்க, நான் எழுதிக்கிறேன். Okay, we have to go for tabulation column. Shall we go for the tabulation column? So what are
Yes,
the
sir.
points we have? 0, 0. Then
root 2, minus root 2.
root 2,
minus
Root 2.
minus root 2. Then
Minus root 2, root 2.
okay, thank you. These are all the points to be examined. And here you have R. This is 12 times of the input x, right? Square minus 4. S is a constant, independent of x and y, whatever it is, right? And t is also, this is 12 times of y minus 1. Right? So you have to make
y square minus.
Minus 4, sir.
Yes, sir. 12 y square minus 4.
This is 4 either. Okay, sorry. 12y square minus 4. Okay. And I have to find RT minus S square. Then I have to make a decision whether it is a saddle, maxima, or minima. Then I have to find the extreme values. Extreme values means a maximum value or a minimum value, right? So do it now. Saying about now.
Minus 4 less than 0. Okay. Minus 4 less than 0. In greater than 0. R is less than 0.
Mute பண்ணிக்கோங்க கொஞ்சம். Mute பண்ணிட்டு செய்யுங்க.
வந்து
Okay, fine. Now I want to replace x with 0 and y with
-4.
0. You get -4.
Less than 2.
-4, this is less than 0. This is 4. And this is -4. And RT is 16. RT minus S square. Focus on 16. RT
Zero.
minus S square is 0. 0. RT minus S square 0 means the decision, you cannot make a decision, right? That's a question mark. Let me see later. Next, if we go with x is equal to root of 2, then you get
24.
22. This root of 2, the whole square becomes 2. 24 minus 4 is 20, which is greater
Greater
than
than 2.
0. And this is 4. And if you go with 12 times of,
Another
yeah,
20 years. 20 years.
everybody, this is y square, are there?
Yes, sir. Vice versa.
No, y square, sir.
Okay, okay. All right. So you get the value as 20. And R into T, RT
400.
400, RT minus S square, 400 minus 16, how much?
394.
380.
3?
84. Sorry.
384, which is greater than 0. What is the decision? Here RT minus S square greater than 0, R is greater than 0. So what is the
Minimum.
decision? Yeah?
Minimum.
Minimum. And let me find the minimum value later. And for this case, when x is negative value, you'll be also getting same 20. You'll be getting 4. And
ಇದು by years, sir. 20 years.
ಇದು
28.
20 da.
The
384.
columns name are
What do you get?
384.
8.
0, sir. Minimum.
That is also minimum. This is also right. Okay. So what is the minimum value you will be getting? What is the minimum value you will be getting? Please check.
Huh?
So you have f of x comma y. So f of you see this f of square root of 2 and minus square root of 2. You get x to the power 4. This is root 2 means 2. 2 square is root of 4. And again, this is also plus 4. Okay. And x square. Huh? What is x square? X square is becomes root of 2 becomes 2. And 2 2s are 4 minus 4. And xy and x into y is this is a minus.
Minus 3.
This is minus 2. So we get
Minus 6.
minus 8. Okay. Then
Minus 6.
y square. What is y? This is root of minus 2 whole
Also
square.
minus 4, sir.
This is becomes 2. So this becomes minus
Minus 4. Sir.
minus 4. So what is the answer? Plus
Minus
4,
3.
plus 4 minus 4 gets cancelled. Plus 4
Minus
minus
6.
minus 8. In the replacing x and y, you will be getting the same value, I think. F of minus root 2 plus root 2. You will be getting the same value. Is it right? Because x is even. This here is also even degree. Even degree for x. X into y. Though it is odd and it can be interchanged. In a value, what is f of
Same also.
same value? So the f attains minimum at this particular point. Here there is no maximum, and we cannot say about anything about this one, but there are some investigation can also be done. Okay. So if so putting in into that at so you will be getting plus root 2 minus minus of root 2, right? Is a minimum value, okay? All right, x is equal to plus root 2 minus root 2 and 0. You have three values. At this particular point, root of 2 minus root of 2, right? We found that this is positive, and therefore this is minimum value, okay? And this is also minus root 2 plus root 2 is also a minimum value. So the function attains minimum at the point, 2 points, right? Either it is plus root 2 minus root 2, or even in minus root 2 and plus root 2. And this is the case where we have to discuss, actually, the case where we want to discuss. So sometimes your university questions, they may not add this one, but anyhow, let us see the discussion, how it was discussed, right? So at 0, 0, RT minus S square is 0, and therefore further investigation is needed. If you எழுதி வச்சாலும் போதும். அந்த further investigation என்ன சார் அப்படின்னு யாராவது கேட்டாங்கன்னா யாராவது சொல்ல முடியுமா? அந்த பாயிண்ட்ல என்னவா இருந்திருக்கும்னு? The answer is saddle point. It is a saddle point. How you can say that it is a saddle point? Now, if you replace x and y with 0, you get f of 0, 0 is 0. And for points along the x-axis, right, where y equal to 0, if you put y equal to 0, you get f of x comma y, right? You get in the neighboring points, you can see that y equal to x. So if you put the line y equal to x, what happens, you see? What is it? And that's the y equal to x substitute பண்ணி பார்க்க சொல்றோம். What is f of x comma y? Can you tell me?
X power 4.
Yes, x power 4 minus 2x square.
So x power 4 plus y power 4.
சொல்லுங்க. X power 4 plus y power 4
minus 2x square.
Minus 2x square.
Minus 3.
சொல்லுப்பா. Yes, I want to take it.
4xy minus 2x
Plus
square.
4. Plus 4xy minus?
Minus 2y square.
Minus 2y square. இப்போ என்ன சொல்றாங்கன்னா இந்த இடத்துல வந்து put y equal to 0ன்றான். அதாவது f of x, 0 என்ன வரும்?
X power 4.
X power 4
minus 2x square.
minus 2x square. வேற?
அவ்வளவுதான்.
So இதுல வந்து x square காமனா எடுத்தோம்னு சொன்னா we get x square minus 2. இப்போ ஆரிஜினை பத்தி தான் நம்ம பேசுறோம். 0, 0 பத்தி தான் நம்ம பேசிட்டு இருக்கோம். இந்த பாயிண்ட்டை பத்தி தான் பேசுறோம். இதுக்கு பக்கத்துல உள்ள ஒரு பாயிண்ட் எடுத்து இங்க சப்ஸ்டிட் பண்ணோம்னா பக்கத்துல உள்ள பாயிண்ட் தான் neighborhood of 0. Say for example 0.1 or 0.2, whatever it is, right? So this value, right, this value will be very small because 0 is a very small value, right? 0.1 whole square will be very, very small, less than 1. So அப்போ இந்த இடம் வந்து பாத்தீங்கன்னா this will be negative.
Negative.
Yeah, that's what it's telling. It is negative ன்னு சொல்றான். In the neighborhood of the origin. Again, for the points along the line y equal to x, அப்போ put y equal to x சொல்றான். So you get put y equal to x in that equation. What do you get? F of x comma x. What do you get? If you put y equal to x power 4 2x power 4, okay?
அந்த ரெண்டு டேர்மும் கேன்சல்
இந்த
இந்த
term
மூணு
cancel.
டேர்மும் கேன்சல் ஆயிடுச்சு.
Yeah, this is minus 2, this is minus 2, minus 4 will be cancelled. So 2 times of x power 4, which is positive in the neighborhood, right? If it is, if it is, you say that 0.1, then 0.1 whole power 4, again, this will be positive in that neighborhood. So what is it states that thus in the neighborhood of 0, 0, there are points where f x comma y less than this one, and there are points which is greater than 0 comma f of 0 comma 0. So therefore f of 0 comma 0 is not an extreme value, and therefore it is a saddle point.
ஃபர்ஸ்ட் லைனும் லாஸ்ட் லைன் இருந்தா போதுமா சார்?
wait a minute. So இந்த மாதிரி எந்த ப்ராப்ளம் வந்தாலும் இப்படி சொல்லலாம்னா இது சொல்லாமலே சேடில் பாயிண்ட் சொல்லலாம். ஃபர்தர் இன்வெஸ்டிகேஷன்ஸ் இருக்கிற மாதிரி நம்மளுக்கு ப்ராப்ளம் வரலாம், வராமல் இருக்கலாம். வந்தால் இந்த ஐடியாவை நீங்க யூஸ் பண்ணுங்க. எந்த ஐடியானா இந்த நெய்பரிங் பாயிண்ட்ஸ் எடுக்கணும். வாட் இஸ் நெய்பரிங் பாயிண்ட்? 0, 0, சே ஃபார் எக்ஸாம்பிள் a, bன்னா அதனுடைய நெய்பரிங் பாயிண்ட் வந்து a must be plus or minus எப்சிலன்ல இருக்கணும், b plus or minus ஒரு எப்சிலன்ல இருக்கணும். a very small value அதை எடுத்து நம்ம சப்ஸ்டிட்யூட் பண்ணி அப்சர்வ் பண்ணி பார்க்கணும். So this is a very best example, right? Put x is equal to, put y equal to 0, and you examine the value, and put y equal to x, and you examine that particular nature. Then you can find if it is less than 0 and greater than 0, then you can say that it is neither maxima nor minima, and therefore you can claim that it is a saddle point. Other words, further investigation is needed சொல்லி முடிச்சாலும் ஓகே தான். இல்ல அடுத்த ஸ்டெப் போய் பண்ணணும் அப்படின்னு நினைச்சோம்னா this is also well and good. But most of the problem அந்த டெல்டா வேல்யூ RT minus S square 0 வர்ற மாதிரி வராது. வந்தால் அது சேடல் பாயிண்டா தான் இருக்கும். எதனால இருக்கும் அப்படிங்கறத நீங்க ஜஸ்டிஃபிகேஷன் பண்ணணும்னா you can do it. இப்போ MCQல வர்றப்போ நீங்க என்ன சொல்லிடலாம்னா இந்த மாதிரி ஒரு பாயிண்ட் வந்துச்சுன்னா அதை சேடல் பாயிண்ட்னு எடுத்து அடிச்சிடலாம். நீங்க ட்ரை பண்ணி பார்த்தாலும் you can also get the same answer. Only of the present only 40. 12:15 முடியணுமாப்பா? டைம் ஆயிடுச்சா? ஹலோ
சார்.
ஓகே, நான் உங்களுக்கு அட்டெண்டன்ஸ் போஸ்ட் பண்ணிருங்க. நீங்க குவிஸ் வந்து இந்த டெய்லர்ஸ் எக்ஸ்பென்ஷன்ல கொடுத்துருக்கிறேன், அதை நீங்க செஞ்சு அனுப்பிச்சிருங்க. தேங்க்ஸ் ஃபார் யுவர் பேஷண்ட் லிசனிங். தேங்க்யூ வெரி மச். தேங்க்யூ.